Does the Earth have an oceanic thermostat? That's what we're going to talk about today. Hi, this is Jill from the North Woods. We're talking about nature right outside your front door, and sometimes a little bit farther beyond it. Today's story is a little bit about what hooked me into science, but a thermostat that controls a lot of the Earth's temperature, something I didn't even know about. And if you're interested in it, there's a lot of great books about it, and it's very interesting. The funny thing is that what really got me involved in science didn't start in a forest or a prairie. It started in the middle of this legendary winter. When I was in junior high school, I was living in the North Woods, and way up in the North Woods, and we had this winter that was over 340 inches of snow. It was bitter cold, nonstop lake effect bands of wind came straight down from the Arctic, blew in through Chicago too. When I was staying at my grandmother's house, their snowplows, half their snowplows were broken, and my military base had to actually go down there and plow out Chicago. It was so bad because the military has great snowplows because you can't say, "Oh, sorry, I missed a terrible event. We had a snow day." We don't get snow days on the military base. But it was wild, and I loved every second of that winter. I had a giant mound, a fort that got plowed into my yard. We had sort of like this side area of the yard, and my dad knew the snowplow guy, and he piled up this mountain in our yard the size of the house. The height of the house. And I dug a fort in there. We played King of the Mountain. We went up to the top of that. And around the same time, we were assigned a few books and a few learning things. One was called The Coming Ice Age, and it was about how the idea was that another ice age was coming, and it talked about the old ice ages, and it talks about a little bit about what the Oceanic Conveyor was, and that's what we're going to talk about today. This book was unforgettable to me, especially when we were having an extreme winter. People who get into birding will have a spark bird. Well, this was my spark winter. This is when I was suddenly incredibly interested in meteorology, and I got really interested in science, and it grabbed me. You can still read that book, by the way. It's in old paperback form. That winter was so extreme that Time Magazine, or Newsweek, had an article about how scientists were thinking about sprinkling ash on the glaciers so they didn't grow bigger and cause another ice age. That's how big this winter was. And then I started reading more and more about it. I started looking up. I'm like, why is this something I just never even heard of? I mean, I was 12 years old. There's a lot of things I never heard of, but it's really something really old, something very natural, and it works in the climate. It works in changing our weather, and it's woven into the very planet itself. The strange truth of it is that, yeah, there is a thermostat out there, or something that behaves like one, and that is the ocean and the ocean currents. So let's talk a little bit about that. If you were to look out from over space, way up there, and then you sped up the time, you would see ice sheets breathing in and out. You would see river bursts through ancient dams, and the sun going through yearly cycles. And then there's basically essentially 11-year cycle sun. We're not talking about that one today. But underneath it all, you would see the ocean pumping warm and cold water around the globe, almost like a hidden heartbeat. And this heartbeat scientists call the thermohaline circulation. And when I first learned about it, it was called the Oceanic Conveyor, like a conveyor belt where it's moving warm and cold water around. So the idea is thermo is for heat, haline is for salt, and warm water floats. Cold water sinks. Same thing in a house, right? If you have warm air in a house, the warm air rises. That's why the second story of your house probably warmer than the first story, which is not so great in summer and fantastic in winter. This room up here is on the second story, toasty warm. The other part of it is that salty water sinks even more because salty water is heavier than fresh water. And those two systems create this looping current that moves heat around the entire Earth, moves cool air around the entire Earth to cool water. The circulation touches every ocean basin, and it isn't fast, it isn't dramatic, but it's powerful and it's consistent and it changes over time, just like, climate patterns change over time. And there are times throughout history, 12,000 years ago, the thermostat got jammed way back at the end of the last ice age. You'd picture that North America got covered in glaciers, in east and west, and the northern hemisphere, I think it was from the north side of things. The area that I live in has something called the driftless, and the driftless is mountainy and foresty, and it is because it was spared some of those glaciers, but everywhere around it, the glaciers sculptured every area of it, and then essentially they melted. The temperatures were gently warming, the rivers were swarming with meltwater, and then suddenly everything flipped. The temperatures in the northern hemisphere plunged, plants died back, animals migrated away, humans shifted their hunting, and almost like overnight. And the cause was a lake that was bigger than all the Great Lakes combined, and it was Glacial Lake Agassiz. This massive flood of fresh water poured into North America. And remember, fresh water floats on top of salty water, and then when it spreads out enough, it prevents the salty water from sinking. And in addition to that, the Oceanic Conveyor started kicking in. The conveyor stalled. So this conveyor that we're going to define here in just a minute, it started stalling, and the northern hemisphere froze. This period was called the Younger Dryas Era. And it was one of the clearest times in history when the Oceanic Conveyor controlled the climate. It wasn't the sun, it wasn't volcanoes, and it wasn't regular orbital cycles like we're used to. The Earth's thermostat clicked into cold mode, and everything changed. 8,200 years ago, there was a smaller flicker. So you sort of imagine, now humans are beginning to farm. Another burst of fresh water entered the North Atlantic, probably from melting glaciers. And the results wasn't as dramatic as the Younger Dryas Era, but it was noticeable. Cooler temperatures, shifting rainfall, river patterns changing, and early farmers were forced to adapt to that. Another time when the solar activity was steady, but this time this was the cause of the oceans. So what exactly is this conveyor? So just imagine this general loop of water inside of the ocean. You can find maps online of it. And warm water rises and moves northwards. Near Greenland, water cools, it becomes saltier, and then the colder, salty water sinks deeper into the ocean and then flows south again through the Atlantic, bending towards the Antarctic, and then wandering into the Pacific. And eventually it surfaces, that same water surfaces centuries later. If a water molecule sank near Iceland today, it may not see daylight again for 1,000 years. It's a slow motion world traveler. This system is ancient and simple and elegant. It is because the heat around the planet changes, and this behaves a little bit like a temperature regulator. It speeds up, it slows down. The northern climates warm or cool dramatically. And you think about it, so if you get glacial melt and a ton of fresh water, cold fresh water, pours into the ocean because the glaciers are fresh water, then suddenly you're going to get this amount of fresh water, which is lighter than salt water, and it starts cooling everything down, freezing up the glaciers again, slowly over time. If it gets very warm, the glaciers melt, put a lot of fresh water into the ocean, and it then forces the warmer, salty water down, and so it starts to cool off again. And this cycle keeps happening. This oceanic conveyor is amazing. And it influences just much more than the temperature. The deep water rises, the oceanographers call this an upwelling, nutrients from the ocean floor, feeding on plankton, fish, and whales. A lot of civilizations grew along the coastlines where this conveyor enriched the local waters. Even ancient navigators depended on this surface currents that exist because of these deeper conveyors beneath. The Polynesians, the Phoenicians, the Greek, the Egyptians all used currents shaped by this unseen motion of the ocean. Motion of the ocean, that sounds good. And then freshwater plumes like rivers from the Amazon also can change those patterns, because you imagine a ton of water pouring out of the Amazon, fresh water, and it then will create this freshwater area in front of the river outlet by the oceans. And so people have sailed into what they call sweetwater streaks, hundreds of miles offshore, because these plumes of floating on top of the salt water redirect migration, trade, everything else. And so this fresh and salty water balance has been wrestling partners throughout human history, and basically, keeping civilizations, alive, and bird migrations alive with that freshwater plume. So, like I said, that brings me back to when I was in the northern woods, and that's what sparked it. So, in this particular case, it turned out, because we didn't have the internet back then, that this record-breaking cold wasn't caused by the Oceanic Conveyor. And it's a completely different ocean pattern. Who knew there were so many ocean patterns? But this one was called the Pacific Decadal Oscillation, which is a slow slosh of warm and cool water in the Pacific. Temporarily shifts and the jet stream opens up the gates to Arctic air. And so that's what kind of happened. And the results were minus 60 wind chills. I remember I went out and played in minus 60 wind chills for a very short period of time. And that's why I dug the fort inside my gigantic mountain, because it was nice and toasty warm in there. 300 inches of snow. Lake Superior was generating snow squalls like a factory. Kids were walking to school on landscapes that looked like it belonged to the Arctic. It was just crazy, because I didn't have a bus where I went to grade school. I had to walk. And so, walking to school, I was just tightly packed up. You only saw little slits of my eyes because I was wrapped in scarves. And so that wasn't caused by that, but reading that book, The Year Without a Summer, the coming ice age, and then having this incredible winter really got it cracked open for me as a young person interested in science. So I hope that helps you learn something about new. So in the end, does the Earth have a thermostat? Not in the way like a furnace is, but the Oceanic Conveyor comes pretty darn close. It works on freezing and melting fresh water. It works on saltwater concentrations, heat and cold inside of the ocean, and it helps redistribute the heat, shapes the climate, influences the ecosystem. And this is not something that you'll see necessarily with, it's harder to see on like year to year. This is more of one of those, whenever you talk about the word climate, it means tens of thousands of years. It doesn't mean like if you say, oh, this is a warm year, climate. This is a cold year, climate. That's weather. Weather is year to year. Climate is tens of thousands of years or thousands of years. But it does change history. And it's something worth watching. There are people talking now that's saying that the conveyor is slowing down. And mostly when we saw these big events happen, like I said, 12,000 and 8,000 years ago, those were major events that happened. But it probably has a much more subtler effect on our weather that's harder to see, just because we look at the sun, we look at volcano activity, we look at weather patterns and those things. But the Oceanic Conveyor, while it can do major things, it probably does minor things as well. So it's one of the great mechanisms that are hiding, with Earth, this humming below the surface, keeping the time with the planets, with the temperatures and fresh water and all of that. So I hope that helps you learn something new that maybe you didn't know before. If you heard about the great Oceanic Conveyor, let me know. And like I said, there are deep dive books about it if you're interested in learning more. If you have any questions or comments, you can put a comment right here in the video channel. You can email me at jill@startwithsmallsteps.com. I hope this helps you know a little bit about weather right outside your front door.